Hello, everybody. So we're up to week 5 now, past the halfway point. Classes do go quickly. Overall, it's a short week. We'll have our class is Monday and Wednesday, so we'll have class both days. But and Thursday and Friday is the Thanksgiving holiday. Hopefully, a chance to relax a little bit. Got a few things going on tonight, so we're going to move on to the next game engine. We'll spend the next 4 weeks on it. Today is just sort of a random walkthrough is what I had planned. Just starting to look at it because it's big and fully featured, has lots and lots of functionality, easy to get lost in. So we'll just kind of get started looking into it today, and then soon. So we'll get to that engine. The proposal of what you're planning to make for your final project is due this evening, I believe. And remember, your final project will just be a proposal. So there's no limit. You can make the big game that you want to make. Right? Most of us have a big, huge game in mind that there's no possible way we can get that done in a classroom. So what we're doing is your final will be the industry standard way to propose a game to the big companies, what you would take to Blizzard or EA Sports or Nintendo, whichever large company would be appropriate for your style of game to finance it. So that's the final product. What's due tonight is basically just telling me what it is. Right. So just a quick write up. Right. It's going to be a platformer game. Some story. A drunk man trying to get home from the bar. So the controls are a little funny, and that's the fun. That's what makes it a fun. That's the abstraction that's going to make it a fun platformer and a little bit different than the typical platformer, because it's simulating a drunk person jumping between platforms or something. That little write up, which will be part of the final project, right? Because the final project is the proposal, but you'll expand on it between now and then. You'll have that proposal, and you'll do some rudimentary drafts of some artwork, right? Maybe just stickmen and different colors, and be like, I want this is going to be the color palette that the game will be, so you can see what effect the colors would have. I guess get into the color theory things there. Hopefully you can do a little bit more of the stickman, but just for an example, just to show what the color palette is, and then you go fill out a spreadsheet and be like, and I need 12 artists to make this happen. Working for 3 months is the expectation, and throwing budget expectations and the whole proposal of what you would take to those big gaming companies to be like, look, this is going to be a fun game. And then the gaming part that you make is proof of concept. So a small sample. If it's something that would have levels, make level 1 with rudimentary artwork. That way people can play it and see that it is a fun game. And some sort of presentation style, which you will share with your classmates in the Modulate discussion board. But the industry standard proposal and what you turn in this week, which is basically just telling me what game you're going to make, what game you're going to do the proposal for, will eventually be part. So you'll have like the storyline now, and then the reason I did it that way, it fits with other class projects. We're turning the proposal and then work on it for a couple weeks, but it also makes sure everybody gets started early and has plenty of time to think about it and go back and forth, make adjustments, and figure out what you're going to do on it. But basically, this week, just tell me what you're going to do with it, and yeah, if anybody has any questions, let me know. And there's no limit. I assume that would be way more fun than trying to make a game we could fit in one semester first learning game development, right? That's very restrictive, and most people coming into this class have lots of ideas of big, awesome games that they would love to make that couldn't possibly fit here. So it's like a start on the big, awesome game you want to make. So this week we're moving on to a different game engine. We started off with something that was entirely scripted. A couple weeks of that, and couple weeks of Game Maker, which I was intended for y'all to use the visual one. They have a scripted version in there, but that would require learning a whole language in 2 weeks. And that's not very feasible. So that was our version, our way to look at the drag and drop interfaces, the ones that are totally drag and drop without going all the way to like Scratch. Has everybody used Scratch before? You know, those puzzle piece things? You've probably used it on like a regular computer with a mouse and stuff. Those are in that design is called Blockly. It's an open source thing Google made. It's actually supposed to go on a phone and done with one thumb. If you've only ever used your mouse for those puzzle piece type of coding, try some of that on your phone because that's how it's intended to be, and it's so much easier. It's clumsy with a mouse. I never can figure out why it took off on like desktops and stuff. Blockly is supposed to be used on a phone screen with one thumb. Oh yeah, in the chat room, Blender is updated since last week. They're constantly updating. Blender has been one of the most popular modeling softwares for a long time. Big open source project, so there's a lot of contributors around the world adding functionality to that constantly. And the next game engine we're going to look at kind of follows suit from that. So I guess we can just jump in and do that because I'm excited to get started, and I forgot to bring a regular mouse with me, but we'll get there in a second. So this is one of the big popular ones. Unreal is one, right? That's one that people think of. That's probably the top engine, has been for a while. It's difficult to work. It's difficult to work with. There's a large learning curve. The biggest reason we show it in class, though, is this is a community college, and I'm not going to ask you all to buy a computer that will run Unreal because your typical computer will not run. Your average computer is not going to run that game. You need to have the biggest, fanciest game GPU just to develop your games there, along with a massive, massive CPU. It would not work on our computer, on the labs, computers in the lab here. It's big, powerful, and we need big, powerful hardware to run it on. And yeah, there's a steep learning curve for that. Unity has been very popular for a while, but in 2019, Unity switched from the developers that created it because they were just wanted to make a game engine to a publicly traded company, and now stockbrokers make the decision, all the decisions for that. And every year since then, those stockholders have made decisions, the board of directors have made decisions that game developers aren't necessarily happy with. Actually, the one this year made the news. Everybody see that earlier this year. So Unity started a new pricing policy. So it charges per download. So if you're on Steam, you put your game on Steam, and somebody pauses the game, goes and grabs a soda or something, and comes back and unpauses the game, you have to pay Unity twice for that. So every single download, people were very, very unhappy with that, which moved a lot of people over to the open source Godot engine, or Godot. I've heard it pronounced that way. I like that pronunciation because that is kind of what a video game is, right? Just moving dots around. It was originally created by Argentinians, so probably the Spanish pronunciation, Godot, which doesn't exactly flow off the tongue. You'll hear it pronounced lots and lots of ways. I usually go with something, I guess, like French pronunciation. The T is dropped off the end. But it's been a very popular one. And the stuff Unity did to run the customers off this year follows what they did to run their own developers off last year. So last year, they didn't make the news like this year's decisions from Unity. But last year, the board of directors and stockholders made some decisions that the developers that had been working on the Unity engine for years did not like. So they left and started working on open source projects, which accelerated the timeline for moving from Godot 3 to Godot 4, and they did some really nice work on it. In particular, the improvements they made to shaders were what finally made me decide to start using it in class. There were a couple things that were I thought were subpar before, but they fixed the things that were subpar. It's a very from Godot forward, it's very nice engine now. So we will need to download it. You don't really have to install it. If you just search for Godot, spelled Go dot, should be right at the top. And it's cross-platform. So download the latest, which looks like it's 4.1.3 today. I'll go ahead and download it. I already have one on my computer. And choose the one that just says Godot Engine. The .NET is using C#. So we're just going to use their internal language, which is based off Python. The C# one is still not complete. There's some functionality that isn't there for coding in C# yet. Whoop. Sorry, let me stop the screen share and close the thing that is going to be giving notifications about that might have confidential information. I always forget to do that. Okay, there we go. Sorry. I apparently closed the browser at some point there. So download the one that just says Godot, and it's cross-platform. Whenever you click download latest, you should see, it should tell what type of computer you're on. If you're on a Mac, it should say for Mac, but you'll see down at the bottom is, or somewhere in this page is one for other Windows, or you can just look at the address. It noticed I was on a Windows machine, so it had /Windows. So obviously there's a /Mac and /Linux as well, whichever one you want to use. One thing I've always liked about Godot is it starts up a lot quicker than Unity. With Unity, we have to go set up accounts. I was never able to do it for the computer lab. Past couple of years, I've taught the game dev classes with Unity, but I was kind of glad to get it over to Godot. Unity takes forever to start up, and it was you have to go set up an account, all sorts of extra stuff. They want to track everything you do, and then use that to install it, and it's huge and massive. Sometimes takes like 10 minutes just to boot up, which in a class period is an automatic waste of 10 minutes. Godot, oh, I guess I didn't download it. I thought I clicked download. Well, you'll just download. Once you download it, there'll be a folder. I already moved it out of my downloads folder. Just move that, unzip it, and move it somewhere else. And there'll be 2 files in there. One of them says console.exe. That's where we would type in like PowerShell or command prompt, right in a bash terminal to do all the game engine stuff. No GUI. We want the one with the GUI, so the other one in there, but you can rename these. And this one, this particular game engine editor was made with the game engine itself. So it boots up at the speed a game starts up and runs really, really quick. And in general, it has a much easier learning curve than the other big engines. Some thumbnails out of the way.
So which one of the things, the .exe or the console.exe?
.exe, not the console. So just the regular one. And first time you should see a message box that says something about the asset library. Just close that. We can access the asset library from anywhere, and these are pre-built assets and plugins and things. And it's generally more useful to access them from inside the game we're making instead of before we even start a new project. Over on the right, you'll see new project, import, scan. If you like download it and there's one in your downloads folder, you would just scan so it could go find the projects and stuff. We'll just create a new project. Obviously give it some sort of name, and I need to put a cough drop. That's right. A rainy all day, and I'm coughing a lot. So I brought a bunch of cough drops in here with me. Hopefully it won't. If I stick it in the back of my cheek, hopefully it won't impede my speech more than it normally is. So some sort of name. I'll call this class 1. We've been doing everything 2D. Let's do 3D first. We haven't done any 3D yet this semester. You probably want to hit this button to create a folder for where you're going to keep it. It does need to go into a brand new folder. It needs to go into a brand new empty folder. It's down at the bottom of the thing. You'll see it already has version control included. Get version control or none, strange options. If you're never looking at version control stuff, y'all probably have heard of, most people may have heard of GitHub, which is a website that uses those protocols. Git is like 99.8% of version control software. So all the others are just like hardly used at all. There are others. And then we need to choose our rendering pipeline. So the forward plus is the one that you probably want to use. So just it's desktop platforms, but in some cases you might want to build for mobiles. So desktop and mobile or compatibility. We'll run on lots of different systems. If you guys on a Chromebook, you'll want to set it for compatibility mode, and then it can build for anything because Chromebooks are very, 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 very inconsistent about the hardware you get. Some of them have GPUs, and some of them barely counts as having a CPU. So they're very inconsistent, and the operating system is like aware of it. So if you're on a Chromebook, make sure you set it for compatibility. I'm just gonna go with forward plus. This will be good for us, and it just has a desktop build for now, but that stuff can be changed. And once you get that set up, just hit the create and edit, and it will boot up the engine editor. So the engine is what actually runs when we run our game, and then this is what we refer to as the editor, or sometimes generically speaking, this people will just call this the game engine because that's where we build the game. The game engine is the code when we run the game, and the editor is how we put it all together. A lot going on here. You'll see there's big. Or we didn't specify whether we wanted a 2D or 3D thing, and it gave us this big 3D space. So one thing that's really nice about Godot compared to others, other large engines, is the 2D and 3D are the same, are treated very, very similar. You can treat 2D differently. There's always more than one way to do things. What we're going to look at today, we'll see how similarities between them. So then you just have to learn one. It's like you learn one engine, and then you can do 2D and 3D in it. Whereas in Unity, to do 2D and 3D, you're really learning two different engines. They have some names in common, but it's different enough that it's like learning two things.
Throws you off.
Mm-hmm. Yeah, it gets confusing at times. You're trying to do 2D stuff in 3D and 3D stuff in 2D. Godot, it's kind of built the same way. It's a big open source project. People contribute worldwide. So if you have an idea that would make a game engine better, you can just go to GitHub and work off of it, and then make additions to the game engine. Quite a bit going on. Inspector panel. Remember we talked about those before. Spent a lot of time in the inspector panel. That each element in our game we can see all the properties for it there. We'll also be able to click and drag stuff from the inspector panel, the properties about the stuff, into our scripts when we get to that. Things about nodes, we'll see that later. History. When you activate version control, there's a Git tab here as well, so that you can roll it back to earlier versions of the game, which is really, really useful in game. And things. Everybody's probably done the essay thing, right? Where you have like essay and then essay underscore final, essay final, essay final version 2, all that stuff. We can do that in one file. That's what version control is. We don't have to have separate files to do that. We just make different versions all in the same file. And we can jump back and forth between them. But that's a different class. So I'll kind of go counterclockwise. Inspector will spend a lot of time there. Come up here, there's some run buttons. So this one runs the game overall. And this one over here, I guess the third one from the right, it looks like the little director clapboard, classic Hollywood director clapboards. That runs the scene you're looking at. So often when debugging, that's the one we want, right? If we're debugging level 8 of a game, we don't want to hit run and start at level 1 and have to go all the way through it. We want to debug the thing we're working on. Here's the button for the asset library where you can download artwork and plugins, but when was it? In August, they started up a new Godot website for downloading assets, both free and paid for ones. So if you have art that you want to sell, that's a place you can sell that. And if you want to just download free or pay for art, it's a website for that. We'll look at that soon. Here's the scripting tab. We'll look at this when we have some stuff to script. It's actually a really nice IDE here that has a really nice IDE built in. Our 3D or 2D view, depending on which one we're going to do. We haven't done much 3D, so we'll do 3D first, then do 2D. Because today is kind of a random pass and just start looking at some of the most important things, and you'll start clicking around and get used to it, and then possibly Wednesday we'll replicate an old game. That's a game like we did with Space Invaders last week. With Godot, we can do something a little bit quicker. We did a test of like level 1 of the original Super Mario Brothers. Might be able to fit that in. Might be able to fit that in a class period, but we'll be here till like that scheduled time, 4:50. That'd be a long class. But we'll do some classic game. Remember, that's a great way to introduce yourself to a new game engine. Sit down and make one of the games, preferably like the arcades from the late 70s, early 80s. Because hardware was so much smaller and restricted back then, any of those games are going to be almost trivial to make these days. And it will still, you'll be able to see the important functionality in the engine. And since this is introduction to game development, that will help you learn game development better, just making lots and lots and lots of those, getting practice at it. As we come back around our main menu, a couple things we'll come back and talk about some menus soon, especially project settings. Obviously, the settings for the project is something we're going to adjust every time. There's some editor customizations we're probably not going to do today, but we'll look at those menus at some point today. Then here's where we create our nodes. So the structure that Godot uses is everything that can go in here is a node, and nodes combine into scenes, and then scenes can be nodes in other scenes. So it is a tree structure. So a little diagram. We have some sort of root node. And then off of that, we'll have a bunch of child nodes. And those child nodes might have more things off of them. And we'll keep piling up nodes that way. Obviously, this would take up a lot of space on the screen. So it uses the indenting. So we'd have like the root. And then it looks like there's 3 things off that. 1, 2, 3. And then the third one, there's some stuff indented there. 1, 2. Then I have 2 things off that. And the indenting version of that, everybody see how those are the same picture? Just with indenting takes up a lot less space on the screen, but everything is one of these nodes that's connected to all the other previous nodes. Or anybody who's got their class where you went over data structures, it's a tree. So we have things, like the ability to turn it into a heat, or it's organized so we can, it's a very organized structure, good for the computer to work with. But that's getting into higher level programming classes that a lot of y'all probably haven't seen yet. You'll start seeing them in your graduate level classes. So everything will create a bunch of nodes, and there's a lot. Like, it doesn't even put the list here. We basically have to search for them, search for the ones we want every time. So we'll get to that soon. And down here is File Explorer. So these are the files. A little organization goes along with some folders there. Our quick examples today, we're probably going to skip much with the files and folders, but we can just drag some files in there. That way we don't have to go to the system File Explorer to grab our stuff. We have a File Explorer for our project ready to go. Yeah, I guess I'll start making stuff. I'll use some shapes here in Godot to get started with, instead of it does connect to Blender. I'll point at the editor menu, so we won't necessarily do this today, but editor, that's the settings for the graphical user interface where we make our game here. I scroll down to like file systems. Under import, notice that it's ready for Blender already. So it just needs us to tell where Blender is. We can do our editing there. For external programs, if we want raster images, that's pixel by pixel, like if we want to use Microsoft Paint. Really like those new updates in Microsoft Paint now that they finally, after almost 2 decades, finally added transparency back to Microsoft Paint. Or vector images, we saw Inkscape. Inkscape and Blender have been the most popular open source ones for 20 years each, maybe a little over 20 years. Oh yeah, over 20 years, because it was both of them are from the 90s. Both of them started in the 1990s and were instead of Autodesk and Adobe, which charged a fortune, and kind of past their heyday. The ultimate examples that, yeah, even with a complete stranglehold on the graphics industry, Adobe cannot make software as a product work. Software is an advertising platform. It's about the only feasible way to make to stay in business. Adobe has a complete stranglehold on the graphics industry, and they're still struggling. Subscription model, and they've been raising their price every month for a couple of years now, trying to stay in business. But using software to sell advertising is very, very profitable, since we are heading industry wars. And in games, that's very, very easy, right? We can put advertising on the website where we download it, or if you're in a racing game, put a billboard there and put an actual ad on that billboard. If you're trying to replicate realism, it would look strange to not have a billboard beside a road.
Many games make up props to slap around. Mm-hmm. Maybe you get paid to actually put something up on the roadside of a GTA map.
Yes. Yes. Yeah, games like that, they do get paid. So they're big enough that they can just make it red and squiggly white stuff, and people know it's a Coca-Cola ad. So, and they'll charge Coca-Cola for it. Indie gamers can't do. Indie gamers can't do that. So you can see there's a lot of settings we have here. We can link to other software, whatever you want to use to edit with. If you really like Adobe, go to Photoshop, and I'm drawing a blank on the name. Adobe's vector graphics. What?
Illustrator?
Yes, Illustrator. Thank you. Yes. Inkscape is the open source alternative to Illustrator. Or choose, if you like Maya, and use Maya instead of Blender. Since Blender and Godot are both open source, yeah. So, yes. Ray shook her head no quick to that. Anybody else that's used Maya probably feels about the same way about it. But we have all those capabilities. We'll see how to link it to Blender soon. That way we can just make our models and we don't have to import them. But importing them is really easy. I might as well show that after the other day. I didn't empty my delete folder. Here's that model from the other day. So I'll just click and drag it over here. Oh, maybe I have to. It's going really slow. We're going to just do a 2D picture. So here's from when I was getting ready. If I just drag this picture over here, we just drag, like, well, we can always do between file explorers. So that's the import options. And now that there's something there, I can look at this other tab next to the scene. And here's all the options on how we import that. Or if we double click on it, maybe it's right click. I could double click and open a window, but maybe I have to right click.
It says that this object is read only.
Oh, okay. Yeah, so I didn't notice the message pop up. Yeah, we have ways to edit it. We'll see some of that stuff. I was just pointing at, here's our import options. There's another import thing we can get to. I thought I would just double click on it and it would open, but I don't see it. We'll see that soon. I was just pointing that how easy it is to generally import it because we're gonna do all our editing somewhere else. And all we do is bring the files in. Start with though, let's just make use the shapes that are here. There's not a lot of editing tools like we would have in Blender for 3D stuff. So I'm gonna make something 3D. So the first thing I'm gonna do is create choose this node for a 3D scene. And yeah, that'll be the root of our scene. So we give it some sort of name. I'll call it world. I just double clicked on it to get the editing. Double click on the name, you can re-edit the name, which you'll probably want to do because in most games you'll have lots and lots of nodes. So now we can start adding stuff to it, like some ground. So I'm going to right click. There's a button, add child node. Or with it highlighted here, there's plus sign up here. Click the little plus sign. Not edit mode. Click the little plus sign and add a node, and we need some sort of node to add to it. And this list is arbitrary. They quit trying to put the full list there because it is just too massive. So you need to search for what you're looking for anyway. We need some ground. That's going to be a plane. Like we saw in Blender, that'll be a mesh. Bunch of vertices connected by edges, then a base. So if we search for mesh, looks like we have 2 for 3D. Notice the names are the same for mesh instance. 2D or mesh instance 3D. And it's also color coded like that. So if you're in 3D, notice our original 3D node was pink. If you notice before the button went away, the 2D node was blue. So 2D and 3D the icons are colorized like that. And then the green ones are kind of set up to go on both 2D and 3D. So like things for a HUD. Those are going to be making a HUD is the same whether it's a 2D HUD or a 3D HUD. So those are in green. Multi-mesh instance is awesome. We'll see that soon. We'll go to Blender and use the generate landscape button and then generate tree button. And we'll take that one tree and multi-mesh make a forest out of that tree. So we don't have to draw all of them very, very efficiently. Dynamically efficiently. So depending on the computer, it'll use your GPU to the best effect if there's GPU, or optimize for a CPU processing and build a forest out of a single image of a single model of a tree that runs really, really well. Obviously, much better if you have a GPU. Then the CPU can handle the one tree, and then the GPU just moves copies of it around. We just want a mesh instance, a simple mesh instance. So that mesh instance 3D. We'll select that. And now we need to come over to the inspector and make some changes on it. So notice right at the top there. It'd be nice if Zoom would let me do like the yellow circle or highlighting on the mouse. So over on the right up at the top, there's mesh. It says empty. we need to assign some sort of starting mesh. Kind of like when in Blender we had those primitives we started with. So like a box is the cube, a rectangle, a capsule, cylinder. For ground, we can just go with plane somewhere in here. Oh, so if you go down to new plane mesh, that'll give us just a big plane. This works our ground for now.
That is where on the inspector thing.
Yes. It says mesh right now. You're just gonna say empty beside mesh.
Yeah.
Click the arrow and come that down. But we might need to change some properties about that. Right, see how we see the overall properties? If we click on this, another menu drops down.
That's weird. Mine appeared on an angle flat.
Probably the angle you're looking at the screen in. We can change it. I forgot. It's a lot better if you have a 3-wheel mouse, and then you can click the mouse and move around. If you're on a scroll wheel, there's keyboard shortcuts that I think I don't think they work very consistently with the touch mouse, but you can always come up here to the little widget in the corner, spin around, look at it from different angles. And if you scroll, going to go in and out, and if you hold Control and scroll, it should pan, but it doesn't seem to pan very well. There's other ways to focus. We'll see how to focus better ways soon. So that gives us our mesh, and if we click on this now, notice how it opened up a whole nother menu over in the inspector panel. Right at the top is size, so I don't know, maybe instead of 2x2, maybe 22x22. That way, here in a few minutes, our character's got enough space to walk around on. And then if you click that, click the picture of the plane over here, that'll collapse that extra menu. That's one of the things you're going to want to do is like click on those menus and kind of look around. Obviously, not memorize it, but kind of read through it and look for some keywords that you recognize and things like that. Look at skeleton. We saw skeletal animations, but really Blender is much better. Even the mesh. Blender has much nicer tools for making mesh, and Blender is fully integrated into Godot. We just have to give it the file path to work with it. So we'll see that very soon. But it does have its own materials. So over here in the spectrum, we have the surface material. This can be a ground. Probably want a color for that. We have different types of material. We will see shaders very soon. The two I have in mind are a water shader and a sky shader with some clouds. I have two fairly small scripts. Shaders are where we code the material so that it's much more dynamic than if we just choose options from a list. For now, let's choose a new standard material. And again, we need to click on it to see the menu with all that options. You can see there's a lot going on this interface, and it's very dynamic, and it takes a while to get used to.
I still don't know what to get with the mesh flat.
Like how is it playing?
It's at an angle. Like
If you come down to the bottom, do you see transform? The bottom of the inspector panel. Probably collapsed, but if you expand transform, is it rotated or something?
It has values in the rotation to 0 something.
So probably set it back to the rotation of 0. Yes, so back on the material, there's a lot of options there, especially just starting out. Albedo is the tint. So this is going to be ground. So if we went green, we would change the albedo of it. But you can start dragging that around. You might want to click somewhere so you can see what tint those colors are. Choose some greenish color for ground. Type in hexadecimal color. Lots of different control over it. And then other things, it's all about materials. Is it metallic? How rough is it? Lots of other things. When you see UV, so UV is basically like XY. That's not a lot. That's not lighting like UV lighting. XY is used in our world. Right? Our world is using XYZ. So for each particular object or things that can move, like if instead of a color we want to put an image there, we don't want to reuse X and Y because those are always going to be distinctly different. So UV are like the next best letters after X and Y to use for that. The standard from algebra, which probably you may not have heard it stated explicitly, letters at the beginning of the alphabet, we'll know what those are. Those are what's given to us for the equation. Letters at the end of the alphabet are the unknowns, the things we solve for, and letters in the middle of the alphabet, like M and K or N, are things we can figure out. Beginning of the alphabet is given to us, middle, things we can figure out, and the end of the alphabet are the unknowns. So after X and Y, U and V are common letters to use.
Which is interesting considering that things like Pythagorean theorem use A, B, C when you're usually solving for X and Y are the most commonly used ones in general now.
Yes.
No matter if you know them.
Yes. The A, B, and C for the Pythagorean theorem is because we usually introduce that in elementary school, long before we get to the X's and Y's. Lots of different things. You can read through that list. Open source projects tend to do this a lot more than the big expensive ones. They went with common names. They might have had all the technical names to begin with, but now there's things like backlighting, normal map, shadows, and the names be very clear. Click through there, see what you have in material. Then click on that to get it out of the way. Geometry, global illumination, we'll kind of skip those for now. Layers are important. These are physics layers. We'll just leave everything on layer 1 today, but that's the layers it can interact with. So if we put this on layer 1 and then say that our player can only interact with things on layer 3, then there's no way our player could interact with this ground.
Which might be what you want.
Yes. And notice when I hover over that, I haven't given it a name yet. Obviously, we can rename it. So layer 1's kind of hard, but it's bit 0. So that is a 1-bit check on those. So, which is much, much faster than anything we would try to do in our code. So we have multiple names and data types and all arrays and all sorts of fancy stuff. It does it in 1 bit. That's common on a lot of our game engines. Here's transform data. Talked about that a few times, right? Location, orientation, and sizing. Whatever 3 words we want to use for that. They use position, rotation, and scale. But where is it at? How is it turned? And how is it stretched or compressed? That's a lot of what we're going to control. So obviously, that's what we'll access a lot in our scripting. Here right now, it's just a mesh. It doesn't have a physics body to it. We probably want to we want that to be a physics body, not just a mesh that is colors on a screen, right? We want it to be processed as physics. So see up here at the top, this button says mesh, should be about the top middle of the viewport right now. It is a dynamic interface, so sometimes your buttons will be in different places than mine, just because you have something different highlighted. So if you ever, while we're going over Godot the next 4 weeks, please let me know. I've spent a bunch of time doing this over the summer. Did a summer camp, yeah. Godot has a much easier learning curve than the other ones. Did a week-long summer camp. There's one person that she'd never done any programming before. Her brother was in the summer camp. He had one 8th grade program, introductory programming course. She'd never done any, and we had open world Go games by the end of the week. It has a very, very nice, easy learning curve. But the dynamic interface takes a minute to work with because you've probably never worked with very many dynamic interfaces before, right? Like we open up Microsoft Word, the bold button is always in the same place. It never moves. It never disappears and then reappears because you select something different. Oh yeah, I guess it's like the highlighting menu, the highlighting buttons in Microsoft Word. And you highlight something, then you get that little sub menu of what it thinks you're most likely to do. Our entire graphical user interface is like that here. So it takes some getting used to on these all the big ones are like that. Godot, Unity, Unreal, I like JMonkey. There's another one that's very popular in Java. There's a bunch of them. There's lots and lots and lots of them. With this top button, actually all these buttons, notice how this top button is the one create tri-mesh static body. So static, it's not programming, not programmer static, that's physics static, so it doesn't move. Programming static means there's one and only one copy. So the computer can use the copy in blueprint, not an object. For those who know what those words mean, it can use the class, not an instance of the class. But this is the physics static, which means it doesn't move. That's what we want from our ground, right? We don't want our ground leaving this. A platformer, we might want some of the platforms leaving, but some of them are going to be static. So if we click that, you can kind of see it. I guess since it's just a plane, all we have is the 4 corners. See that diagonal blue line? We'll be able to see it better when we get to, we'll put a capsule in for the character in a moment. That is the collision shape. So notice it added 2 things. It added a static body 3D. So now we have 3 parts to this thing. The mesh itself, the image of it, the static body, and the collision shape in it. So 3 different parts. The order they're in here is not the best order, but notice the 3 nodes make up that ground. So that is actually, that's what we would call a scene in Godot. And that scene becomes its own node in the world scene. So layers and layers of those words that we'll be using lots of over the next few weeks. Everybody get that far? Who's following along? So now we'll probably want a character to put on here, right? We don't want the character to be a child of the ground. Probably want it to be on the world. I'm doing this in a weird order. Ultimately, we would do this in a different order. I'm gonna do like we did on the ground and make the mesh first, and then we'll hit a problem and come back afterwards. But we want it to be a child of the ground, so I'm going to select the ground, add a new node, and let's look for another mesh instance. Add a mesh instance 3D. And I'm going to use a capsule. It's like a cylinder that's rounded off at the ends, or take a sphere and stretch it out. That's a common starting point for 3D, right? While we're waiting on the good graphics, we use a capsule because it's about the shape of a human body. If I click on this to look at the size, you'll notice it's 0.5 meter in radius and 2 meters high, so it's about the appropriate size of a human. A human should be 1.8 meters high.
How'd you get that there?
Oh, I click on the picture of the mesh. Pulls up all those properties about it.
It was what was it? It was
Capsule. Or yeah, it has a big long name. New capsule mesh. Or cylinder or box. Feel free to choose one of the others. Probably one of the 3D shapes, right? Our character is not a plane. Our character is going to have some depth to it. Capsules are pretty common. I'm going to move that up. And if I push, I'm going to push the letter F as in focus. Notice how it kind of changed, screen changed. So now if I zoom in and out, it zooms right to that character. If I go back and select the ground here, I push F, now the ground has focus. So zooming in and out goes right to that character. So if you're on a touchpad like this, it'll work better. I forgot to bring a regular mouse in with me. We'll go over the mouse pivots after a break. I'll grab one out of my office. We can start with this. So there's our character. Then we could do the same thing. Click mesh, try mesh static, but that would be a problem, right? Because
Oh yeah, we don't want it to be still.
yeah, our character is not static. Our character is going to be dynamic. So what we would normally do first instead of that, actually, I'm going to grab this and move. Well, I'll show the arrow. I'm going to select world, and under world, instead of mesh, start searching for character. Notice there's character body 3D. That's the one we want to use. So let's create a character body. And now we can drag that mesh over to be a child of that character body. One little issue here. See that highlighting? So we have the move and the move arrows, and those little squares are for scaling, and then those circles are for rotating. So there's our transform tools. But the character.
For some reason those don't appear for me now.
They might be turned off somewhere.
Oh, actually, if you click on for whatever reason by default they weren't there, but if you click on the little mouse icon on the upper left, it makes it appear.
Yeah.
See, to the left, you're over.
Oh, okay. I was looking for a mouse shape.
Not yeah, no. The cursor, sorry.
Yeah, cursor. There is a button that looks like a mouse too. But it's not. I was looking for it and I was like, I don't see the mouse one.
Apparently balanced. But by default on here, so I don't know why. I guess.
Yeah, so like if I switch over to the scale tool, I can only see the scale.
Yeah.
If you click on the cursor, you can see all of it. But they're in a different spot. So I'm going to select the graphics for it and switch that back to 0, 0, 0. So now they have the same location, orientation, and scale. So the character body one, before we start renaming these, this is our logical one. This is what we're coding. And then the graphics are something entirely separate. Probably give it names now. So double click on it, I'll call this player. And then I'll click on that mesh instance and I'll just call this graphics. Make it clear what each one is. You see a little warning there. Node configuration, it has no shape. So we have the logical aspect, the transform data and other metadata that see how much we can fit in. I can talk the entire rest of the semester about the other data in there, but we want to see more than just that, right? So there's a lot of stuff there, but one of the most important one is it doesn't have a shape. For now, we can think of it as our transform. We know how where it's located. We know how it's rotated, but that's all. We don't know what shape to rotate in space. If I grab that little thing and rotate it, we can see our mesh. Have the logic one selected, and if I rotate it, the mesh comes with it. Because the mesh's transform is based off that parent object's transform. The child stuff will always come with the parent. But we need a collision shape. So with that highlighted, click the new button node and search for collision shape. In particular, collision shape 3D, but I'm going to probably not be saying the 2D and 3D because it's going to be obvious whether we work, which one we want, depending on our class example, right? Here in a few minutes, we'll get to a quick random pass of the 2D example, but or maybe an hour or so. And I'll just call this shape. This is the physical shape of it. It was a collision node.
Fixes attached to players.
Okay, and you can drag and drop them between them. So world, that's our root node, so we can't drag that anywhere else. But like, I could take the collision shape from the ground and put that on the player.
I'm thinking from one of the graphics mark first, the player, then it was collision shape. So then it gave like that weird moment.
Oh, okay, yeah. Yes. As long as they're indented at the same level.
Yeah, they did it the same way.
Yeah. So what he was saying was his shape was under graphics. So still get the warning because the logical node, the one we actually control, doesn't have a shape still. The graphics have a shape. So click and drag that under player. So now it has a shape, but we need to choose what shape that is, and there is a capsule shape. Or if you went with the box or the cylinder, choose the appropriate one, and the default should be the same size as that default we used. I can kind of move that up. That's the basic idea starting there. We're going to see much more detailed examples, obviously, and actually doing stuff. But you see the commonality there? Probably would have made more sense to make this a child of this. Okay. Do the static body and then make our ground a child of the static body. And then the collision shape, child of that. That way it's a little more consistent. Then we have ground. I did that just to show that order doesn't matter. But organization and consistency goes a long way. So all I did was reorder it. The ground, you'll be fine if you want to keep it in the same order. Let me undo that. One too many. To have this. So our ground here is in a different order than our player, right? That could be confusing at times later. So what I'm gonna do is take the static body 3D. Right? Our player was the character body. So to keep things consistent, I'm going to drag that out and make it a child of the world. Put it out at the most unindented, or the first indentation level. Then I'll grab that mesh and make that a child of static body. So I get names now. So and graphics and shape. There's consistency. You know, got this and leave it up. Now it's consistent. As the games get big and complicated, which will they will very quickly, even in small games, a little bit of organization goes a long way. So you want to keep things like that in mind. Take a moment to do it along the way instead of trying to wait until you have 1,000 things and be like, oh, I have to organize this. Because then you'll spend a long time dragging stuff around. We'll also see some other stuff. We'll save these in different files instead of all in one place. But that's just preview now. See how everybody see how the nodes go together? Oh, we need a script for our player. So I'm going to the player one here. And there's that plus sign I was clicking to add nodes. If we go to the other side of the search bar, this little
That looks like a scroll thing.
it looks like a scroll. That's the add script button. If we click this, since the player was a character body 3D, notice about halfway down those boxes at the top, it has the template, and it gave us the character movement. It's trying to use the character movement template. which is probably the one we want. For our quick intro example here, just saving everything at the top level. Obviously, that'd be bad form because we're going to have lots and lots and lots of stuff. So we'll probably eventually want lots and lots and lots of folders to organize it and keep it straight. But for now, just that top level is fine. So I'm just going ahead and create. Jumped over to the scripting thing. So they based it off Python. It compiles into C++ code. So at runtime, it's C++ that's running. So it's not a slow language like Python. I'm just gonna hit run and then come back and start editing that. Notice we have a speed, jump velocity. We'll talk about it in a second. But just putting that script in and then come over here. The third button from the right is run the current scene. And we have to save it. World sounds like a good name.
It says domain scene has ever been defined. So like,
Oh, so if you hit the overall run button,
oh,
it wants you to define the main scene.
gotcha.
The third one from the right looks like a director's clapboard. That runs the current scene. Or you can just choose the current scene for
That's fine.
the default story. We do have to save it, so I'll just hit save. It'll name it. We already renamed the nodes, and it looks at the root node and tries to give it that name unless we want to change it. Can't see anything though. There's an important thing we're missing. Yes. We need a way to see stuff. We don't have a camera in that scene. We're kind of like when we were setting up Blender, right? We put a camera in there and then took a picture of that at the end to get the animation. The camera is what sees. So this is just an editing viewport. So I'm going to go to player. This is the way I like to do it. I'll go ahead and show you the way I like to do it. So we can put a camera anywhere, hold it stationary. I'm gonna do a third person view here. And I like to add an extra little step in because we want a camera. It's a lot easier if our camera moves on it, like at the end of an arc. It stays a certain length away instead of moving the camera completely arbitrary. So what I like to do is go to the player and add in just an empty node. It's something that we do an awful lot. So I'll choose an empty node 3D.
What did you type in to get
Just a node.
just node 3D and that's all it is?
And with that selected, make sure it's a child of the player in the indenting. I'll usually, for third person view, I'll usually put that up about where the shoulder of the character would be. And really what that is, I'll rename it now. It's camera pivot. That gives us a spot to spin around. So our we'll make the camera a child of that, so that it's kind of it'll be invisible, but think of it like an arm, like a boom attached to the shoulder. Right? It's like a bar coming off the shoulder, and the camera's hanging out on that bar. So no matter how the character turns or moves around, the camera will stay in that same spot. And putting an empty node there makes rotation a whole lot easier than if we were trying to define it ourselves. Kind of like if you just hold something at an arm's length, you swing your arm around, it's still the same length away. So it's kind of like my shoulder's doing here. It's the pivot point that our camera spins around. And then from that camera pivot, I'll search for camera. That's just the way I like to do it. Instead of just putting it arbitrary.
It's XR. XR. No, I said what is that?
Oh, XR camera is cross reality. That's the thing basically Meta hired 42,000 programmers to do a couple years ago. They standardized virtual reality and augmented reality. So yeah, it's a regular camera, only it's already set up with the inputs from the headset. So it's already set up with the motion tracking for the headset. No, that's free. No, PlayStation, Xbox. you can't publish for Nintendo unless you work for Nintendo. And only Nintendo can publish for Nintendo. But PlayStation, Xbox. What's the other one then? Forget. Yeah, basic consoles. I guess there's more than just three. But I was gonna rattle off three, and I can only think of two.
Hey, PlayStation, Xbox, and Nintendo are really the only ones left.
What am I thinking of then? Oh, well, two.
If you're
Yeah.
thinking of like the Switch, that's Nintendo.
No, it wouldn't be a Switch. And Steam, yeah, if you have a Steam console, Steam, that's the same as the website.
Yeah.
You just publish a game that you just publish on Steam, and you use your Steam account for that. But I thought there was
There's Steam console.
a Steam headset. They're not very popular, but they exist. There's also a Steam handheld that's like Switch. It's incredibly not popular. Oh, Stadia. That's what I was thinking of.
Stadia is dead.
Stadia, Stadia.
I think
Yeah.
yeah. business a while ago.
They quit making them.
Yeah.
They just went out of business entirely. Like they're gone now.
Earlier this year.
Really?
They quit it again.
I heard someone lost like 4,000 hours. With it.
Yeah, a lot of games were warning players. Games that are cross-platform were warning players for months that Stadia's closing. You need to make sure your account's up and down. It will no longer exist.
Okay, they reactivated it this spring, but they may have already closed it again because it did not.
I didn't even know they react. I thought, wasn't it spring when they closed it? Was that last year? Time flies.
Well, they closed it 2 years
I
ago,
think it was like 2 years ago. It's been a while.
and they brought it back this spring, and I haven't really followed
And
after
then
that.
recently it's discontinued.
I just remembered it in the spring because I was like, why? Nobody liked it the first time. Probably not going to take off the second time. Maybe it was just to unload inventory or something, and it didn't work out like they planned.
I don't know.
Yeah.
It's a good idea in theory. The problem is we don't really have the infrastructure to work with that sort of thing yet.
Yeah. But they would be one that charged. I think there's other ones out there, small ones, but in general, I guess it's just the two. Xbox and PlayStation charge. Most of them are free to build for their console. Or build for the device. Yeah, so XR is the virtual reality camera, but it just already includes the nodes that have the motion tracking from the headset. So we don't have to set up our input manager. If I zoom in here now,
Did you move the camera?
so I haven't moved the camera yet. I'm getting ready to. So, well, I'll move it back in the positive Z and kind of see which direction is forward, right? We'll see which way the camera faces by default. So negative Z is forward. Oh, it's pretty standard across the board. X, Y, Z, and RGB, we keep things in that same order. So X is pretty much always the red axis. Y is almost pretty much always the green axis, and Z is pretty much always the blue axis. And the arrowheads, the arrows point in the positive direction. So
I will say the problem I see with this is you're going to be staring at
I was gonna move more over here, and then maybe up a little, and then grab the X rotation and bring it down. And then there's a little preview button over in the left. That'll work. Not worried about perfection here, and generally our cameras move, right? We'll have the mouse zoom in and out and rotate and go up and down. Mouse does the camera, the keyboard does the movement, seems to be the most common. Or fit with a lot of 3D games.
the preview button.
Over in the left, top left, when the camera's selected, and you can see what the camera's going to look at. So now we should be able to hit run and see what's going on.
Not through, but
So everything has a collision shape, and so those shapes stop when they hit each other. No lighting though.
yeah, that's just what's
We'll see lighting soon. Skies are one of the shaders I have in mind, but now if you come up to the top of the viewport area, the ellipsis button, the more button, the default lighting and environment that we see in the background, we can just add those in. Normally you don't want to do that because you probably want to create one that fits your game, not that generic one. If you click that more button, you can add the default lighting and stuff. So then we have lights. Oh, we never gave our character any color. So let's give the character color.
So you did add in, how did you add light in? What did you?
So click the little more button up top, and you'll see a button for the scene, which is the background, the environment, and the light, which is just the default one we have for the editor here. We can include those. They're already included, so my buttons went away. If you haven't added them yet, you should see an add the scene button.
Okay, yeah. I tried clicking it, didn't do anything at first, and I clicked it again, it did. I don't know why. First time didn't apparently be enough.
Yeah, and have a sky shade. A sky shader is one of the ones I was going to look at to talk about shaders when we get there. I forgot to give the player graphics any colors. So I'm gonna come back to the mesh. Select that mesh and add material in. Just a standard material, but for now, I'm just gonna add something skin color to be over here somewhere. This wheel goes in HSV colors, so like red is considered 0
As
degrees.
you get there,
Oh, it selected the mesh, and then over in the inspector, there's surface overlay materials, and when you
okay.
the new standard material, and then when you click on that, the albedo is the color, the tint of it. All right, so now if I hit run, it falls down. But remember how we use that default character script? So that goes to the arrows, and move forward, back, left and right, and jump are there already. Physics jump. So if we're moving forward and jump, we keep moving forward.
How did you give it? What if you go on the surface?
Oh, just keep falling.
Okay.
The surface is stopping us from falling.
I see.
And then just hit the little X to close it. That was pretty quick, right? You get just the starting point, and then from there, it's more of the same thing. We're gonna spend the next 4 weeks doing more of the same thing. I want to show the controls I like because you notice it was just forward and backward, and if we had a character with like a face, that model we made the other day, we would just be walking backwards, all strange like, and we didn't do a backwards walking animation. We only did a forward walking animation. So that would look very, very strange. Probably want our character to turn around, like y'all pitch and roll. Remember those words?
Yes.
Y'all, boats and planes. So make sure I'm on the camera. So y'all is spinning around the vertical axis. Pitch is back your sideways axis, so back and forth. I guess it works really well on a boat. So the waves if you're going with the waves, so the pitch is going that way, and then the roll is side to side.
I have a good way to do it would be also be a plane turn left, turn right for y'all. Roll is tilt left, tilt right.
Yeah, you roll
And then-
left or right, and that forces the plane to turn.
And then pitch is point up, point down.
Yeah.
So,
Yeah, those are the standard words for that. So I like that type of movement, at least for starting. It's quick and easy to put in, and we'll introduce the input managers, but it's probably a good time for a break first, right? We've been at it for an hour and 15 minutes. Then we'll see the input manager, and then we'll throw together something 2D, not a full game this time, but we'll make it a full game soon, and see the similarity, how Godot treats 2D and 3D similar. We can do it different ways. We could do it entirely different, but I'm gonna go over the way that is the same, because then it's a lot easier. We don't have to learn it once, but 10 minutes sound good to everybody? And I could go for a sip of coffee. My laptop says 2:15, so we'll get back to it at 2:25. And I need to plug up my laptop. I apparently forgot that step when I was getting ready. Battery's about to go out. See y'all in just a moment.